Welcome to the project demonstration of maximum power point tracking using fuzzy logic for PV systems. So in this project we are using solar panel and we are going to apply the fuzzy logic along with MPPT and buck converter. These three are going to be applied in our project to get maximum power to charge a battery pack in less time. Generally, without this setup, we can charge a battery pack directly with the help of the charging circuits. Means solar panel as input to the charging circuits and from there to the battery pack. But here the problem is we are using the 12 volt 5 watt solar panel, and when we kept this solar panel under the sunlight, then we get maximum of 17.5 to 18 volts. So that is the rated voltage of any 12 volt solar panel. So we can see the ratings of our panel which we are going to use is, so we can see that maximum power is 5 watts and voltage maximum power is 17.4 volts and the current is 0.29 amps and open circuit voltage is 21.40, though we are using a 12 volt solar panel. So when we keep this under full sunlight, it can provide us up to maximum of 21 volts in open circuits, and when we keep this solar panel to charge our battery pack through the charging circuit, it can provide up to 17 volts. But the charging voltage for a 12 volt battery pack is minimum of 13.5 to maximum of 14.8 volts. With that voltage region only the system can be charged, means the battery can be charged. The above voltage is waste, nothing but it may harmful to the battery pack. So then the point comes to MPPT, that is the maximum power point tracking. So the purpose of the maximum power point tracking is, in order to maintain the, without this MPPT, the system, in order to maintain the 5 watts of power. So when the voltage increases, as we know that the power is going to be the multiplication of voltage and current. So whenever voltage is increasing, in order to compensate the power equal to 5 watts, then the current will be decreased. So then the outcome efficient power is very less comparatively the 5 watts of power whenever the voltage is not utilized for the battery charging purpose. Then the MPPT comes to the picture. To charge a battery in efficient manner, it will decrease the voltage when it increases above 14.8 volts. So that whenever the voltage is getting from the solar panel is 15.5 volts, the remaining 0.8 or 0.7 volts will be buck down by the this MPPT circuit. So which we are using the MOSFET here. So this is the MOSFET, so which will act as the MPPT circuit purpose to buck the voltage which is above 14.8 volts in order to maintain the 5 watts of power in efficient manner to charge this battery pack. And the next, whenever the voltage is less than 13.5 volts, then another problem is if we are getting the 11.5 volts, that is not sufficient to charge our battery pack. Then what we need to do? We need to do the boost. That is minimum voltage required to boost up is 8 volts. So whenever the solar panel voltage is 8 volts to the 13.4 or 13 volts, in that region the system will boost up the voltages till it reaches 13.5 volts. When it reaches 13.5 volts, then we are going to controlling the off time and on time to this MOSFET circuit by using the microcontroller. So it's a closed loop manner. So just the flow is, we are going to provide the solar panel supply over here, and from there the output is given. This is the output. I'll show you that. Right, so the output is from this charging circuit is input to this buck converter. So we are proposed block diagram of our project is, which has the combination of solar PV array along with buck converter parallelly to the MPPT circuit, and in the closed loop manner the system keep on checking the output voltage, then that will be given as to the battery pack as a load here. Okay, so these two are the loads and we are going to charging the battery pack. So here see, there is the input from the solar panel charge circuits to this buck converter, and from there the output is again fetched to the MPPT circuits in order to maintain the output voltage between 13.5 to 14.8 volts, and the output from this MPPT circuit, the buck converter, is given as input to the battery pack. Okay, this is the closed loop manner. Here the output from this solar panel, the input from the solar panel is continuously measured by this microcontroller in order to do the whether should decrease the voltage for the buck operation or else boost the voltage. using the Cuck converter. That will be decided by our microcontroller continuously in this project. Okay, so this is the secondary source to charge a battery pack. Just to charge a battery whenever the sunlight is not available, just we can keep this 230 volts AC input from the grid directly. We can charge a battery pack, and that can be charged in a duration of 4 to 5 hours continuously. Directly just on the power supply to the grid, then the light indicated the battery is charging from the grid. Okay, so while our project demonstration, it is not our project in parts. Directly we can just get the power supply from the solar panel to the battery pack through this MPPT and Cuck converter, and it will be controlled by the SPIC microcontroller. It will get the power supply also from the battery pack using this switch. So ratings, coming to the ratings, as we discussed, 12 volt 5 watt solar panel we are using, and here the Cuck converter is consist of 2 transformers, but these transformers we are utilizing them as inductors, as we know that copper coil will be there inside that for the primary and secondary. Primary is the more turns to get the more current, and secondary is the less turn to get the sufficient voltage, so that we can do the boost operation with help of this Cuck converter properly in efficient manner. And the load is going to be, we have considered the 12 volt LEDs of 5 watts, and the coming to the battery pack. So here you are using the 3 4 volt 1 amp batteries. So totally we are using 9 3 volt 4 volt 1 amp batteries. In that, these 3 are in series, these 3 are in series, and these 3 are in series. So 12 volt 1 amp, 12 volt 1 amp, 12 volt 1 amp. So these 3 are in parallel sets, so that we will get maximum of 12 volt 3 amp of power is available from this battery pack, which is rechargeable through the solar panel. So just we need to connect the solar panel directly from here, and there is a grid. So here just we on this, as we can see the light is continuously on and off. That is indication of it is measuring the voltage from the input solar panel, and also do the buck and boost operation. Nothing but buck operation from this MPPT circuit, and the boost is happening from this Cuck converter. So it's a closed loop manner. We are going to maintaining the sufficient power to charge and battery in less time. Thank you.